let's look at a few more ways that an absolute value graph can change when we shift around the graph using different numbers here in the formula for absolute value. So if we take this y equals a times x minus h in absolute values plus k, we talked about how last time the h and the k move the graph around. So this graph would be shifted to the right one and up 3. Okay, and again, that's in a previous video. If you want to go back and review that, you can. What we didn't talk about, though, in that video was how this 2 affects the graph. Okay, and we're going to talk a little bit about vertical stretches and compressions. Okay, imagine you have your absolute value graph like this, and if you were to just pull on both ends of the graph, okay, and if you were to pull this out, well, if you were to stretch it, it would get kind of short and skinny as we tried to stretch that apart. Okay, now imagine that we have our absolute value graph and we compressed it. So we have it in a vise here, and the vise is going to close on it this direction. Okay, you might guess that that would make your absolute value short and fat. So it kind of spread it out there or squish it. And that's what we're going to be looking at today, how this a value will change the function when we graph it. Okay, so let's try the first one here. We're going to do this in 3 steps. The first thing we're going to do is we're going to graph the parent function. And we have our parent function right here in the middle. And we said last time that some good points to pick are -2, -1, 0, 1, and 2. Okay, just it gives you a good picture of this absolute value graph. We also said last time that if you take the absolute values of all these, it'll just make nice positive numbers. And if we graph these, we've got -2, 2. We've got 0, 1, 0, 0, 1, 1, and 2, 2. And we said that the actual parent graph would look like this. Now, when we're graphing these, when there's a number in front of our absolute value that's going to, in this case, you'll see it stretch the graph. What we're going to do is regraph this. So that takes care of the first step. We just graph the parent function. Our second step is we're going to now graph the stretch or compression, and sometimes you might get a flip too if your A is negative. Okay, right now it's not flipped because that 2 is positive, so it should be looking up. And then from here, we're going to go ahead and graph the stretch. To graph a stretch, we've got our x and our y. In the parent function, we just have plain old x and plain old y, and we plug them in. Here, though, whatever the x is going to get doubled, so the y should be twice as big in this function. So let's add another little row here and look at what 2y would be. Okay, if I were to double that y, what would it look like? So what's going to happen is because there's a 2 out front, I'm just going to double each of these y values. Let's see what the graph looks like. Okay, so 2 times 2 gives me 4. 1 times 2 gives me 2. 2 times 0 is 0. 1 times 2 is 2. And then 2 times 2 is 4. And now what I'm going to do is I'm going to graph now the stretched function. And if you look at this, it's going to look like it's stretched out. So we still have 0, 0 in the middle. That's going to be the starting point. But then we've got -2, 4. We've got -1, 2. We've got 1, 2, and 2, 2. And now you can see that our absolute value graph kind of got stretched here a little bit. So it's kind of getting tall and skinny. So that would be what we call a vertical stretch. And now, once we've done that, so we've just graphed the stretch, we're going to go ahead and shift the graph around. Remember from last time that this shift is telling me that the 1 here will show me that I'm going right 1 and up 3. Okay? So all of these red points, we're going to finish this graph by going right 1 and up 3. So I'm going to take this middle point, this vertex here, I'm going to go right 1 and up 1, 2, 3. Put a dot. Let's go to this one at the left. I'm going to go right 1 and up 3. Put a dot. At this point, I'm going to go right 1 and up 3. Put a dot. Now from here, we're going to go up, right 1 and up 3. And then from here, we'll go right 1 and up 3. And we should be looking at our absolute value graph there. Oops. Right 1, up 3. There we go. And that would be the final graph of your absolute value. And I'm just going to go back just to show you what the final picture looks like. I'm going to erase all the extra points here. That's what it should look like when you're finished. Okay, and we can do that by shifting things around, but we have to do the stretch and compression part first. Okay, so we just took care of those 3 steps. So these are the 3 steps you're going to want to look at when you're doing these problems. Okay, let's try the next one. We've got -3 times x plus 2 in absolute values plus 6. And we're going to try and graph this one more time. So we'll start by graphing the parent function. You're going to get good at graphing this to the point that you may not even have to write the points down, but I'll put them here one more time for you guys. I'll just fill this in. Oops. Fill this in real quick once more. We got 2, 1, 0, 1, 2. And again, it makes absolute value graphs make a nice little V shape that looks like this. Okay. And I know there's other ways to graph these too, but this one will help you when we get to later functions that are shifted. This kind of thinking will help you when they don't always look like a perfect V. Okay, so now to graph the stretch or compression, in this case it'll be a stretch, what we're going to have to do is we're going to have to, again, look at your y values, and that number in front of the absolute value is going to get multiplied by each of the y values on this column here. Okay, so let's go ahead and do that. That would give us the point -2, and this would be -6, -1, -3, 0, 0. This would be 1, -3, and this would be 2, -6. And you can notice here that this actually just flipped our graph upside down. So we still have 0, 0 here, so we still have 0, 0. But let's go ahead and graph the other ones. We have -2, -1, 2, 3, 4, 5, and 6. We've got -1 and -3, which would be right here. We've got +1, 3, and we've got 2, -6. So you can see that this actually flipped the graph upside down. So this is what we call a flip, and then we stretched it too. So it got tall and skinny. All right, so now that we've done that, we've multiplied each of the y values there. We just graphed the stretch and flip. We're going to go ahead and now graph each point by shifting it h and k units. Remember that plus there is means minus a -2, so that means we're shifting this 2 to the left for each point and up 6. So I'm going to be shifting 1, 2, 1, 2, 3, 4, 5, 6, and there's my vertex. Should be at the point -2, +6. From here again, I'm going to shift this left 2 and up 1, 2, 3, 4, 5, 6. Put that. We'll shift this one left 2 and up 1, 2, 3, 4, 5, 6. Put a dot. Okay, that takes care of this side. We're going to shift this left 2 and up 1, 2, 3, 4, 5, 6. And I'll let you check my last shift there. You can check that on your own time, but it should go right there. All right, and we're going to go ahead and sketch our graph. Okay, so the blue graph should be our final answer for that problem. Okay, we sketched the parent, we sketched the stretch and compression, and then we shifted it using the H and the K in the formula here, like we did in the last video. We're going to take one more, and in this one, we're going to look at what we call a compression. Okay, so we'll take a look at how that works out. And one more time, I'm going to graph the parent function to start. Okay, I'll do this in green. I'll stick with my color scheme here. So we'll do this one in green. Again, I've got -2, -1, 0, 1, 2, and this will give me 2, 1, 0, 1, 2. And if I graph this, again, you should be very good with this by now. Graphing the parent function should just look like a nice little V shape starting at the origin. Now from here, we're going to take the parent, all right, and we're going to have to now have each of these numbers because I have a 1/2 in front. Anytime you get a number that's less than 1, it's going to actually compress the graph, okay, which is going to make it short and fat. So it's going to kind of widen it out. Imagine that there's, something pressing down on this absolute value from, that's kind of crushing it against the x-axis here. So let's go ahead and see what this looks like. If we take now half of each of the y values, so instead of multiplying by 2 or 3, we're going to multiply each of these by half. So half of 2 is 1. Half of 1 is going to be 0.5 or 1/2. Half of 0 stays 0. Half of 1 is 0.5. And half of 2 is 1. So you can kind of see from this, we've got the point -2, 1, so on and so forth. So we get the 1/2 of our y's to get that column. So this will take us to -2 and 1/2, -2, 1, right here. This will take us to -1, 1/2. We'll be at 0, 0. We'll be at 1, 1/2. I'm losing points here and I don't know why, so sorry if these points disappear on you. Yep, there they go. And then we've got 2 and 1. Let's try this one more time, see if it works. Okay, so our points should look like this now that we've got this sketched. All right, and we're almost there. We've just got to shift the function now. So we're looking at a shift of to the right 3 and down 4. So we're going to take each of these points now and shift them right 3 and down 4. So let's go ahead and take this graph. We're going to take it to the right 1, and let's do this in blue. We'll take it right 3, 1, 2, 3, and down 1, 2, 3, 4. So there's going to be the center. I'm going to take this one right, 1, 2, 3, and down 1, 2, 3, 4. Notice my point is still in the middle there because it's halfway. From this point, I'm going right 3, 1, 2, 3, and down 1, 2, 3, 4, which will be right here. And I'll let you check my last 2 points on your own by shifting those, but they should end up here. Okay. And you might notice that for each of these absolute value graphs, it really works a lot like slope. I just don't want you to get in the habit of thinking it'll always be a rise over run. When you get to parabolas, they have this weird shape. So the way I'm showing you this now will work for any function that you do down the road. This way is going to be better in the long run. So if you want to use that slope trick, that this is a rise over run of up 1 over 2 because it's 1/2 in both directions, that works for these types of problems. Just don't make that mistake when you get to parabolas. So again, graph in this case, compression. We shifted each point, so now we're all good to go. So our graph is finished. And that's just how you can shift any absolute value graph when you have a number in front of the absolute value other than 1.